Hello everyone, this is the last part of chapter 1, and in this part I'm going to cover the drilling cost and maybe the drilling rate slightly. We're going to cover the AFE, which is authorization for expenditure for drilling. So if you want to do any drilling project, you need to basically list all the expenses and cost for this drilling and estimate those numbers. Depending on the company, it may be different. For smaller companies or for larger companies, they have different goals regarding this AFE, but usually they need to plan ahead and consider all the tangible and intangible costs that they have, and this include basically the dry hole and completion, workover, any type of costs related to these things before they basically started drilling. So there are these costs could be the time sensitive cost. It could be the cost of the equipment, for example, tubular equipment, wellhead equipment, completion equipment. These are part of the tangible costs or intangible costs, such as location preparation, drilling fluid, drilling rig tools, rental, service, transportation, supervision, and admin, and put all these costs together and basically estimate how many days you have that, and basically have a price for this listed, right? You also need to consider the contingency and all other factors in addition to that cost, and have a total cost. So usually the drilling cost with depths, of course, increases as the time passes, because for example, one of the things that you are doing is to have a drilling rig rented, right? And that drilling rent could be per hour, or could be rented per day, and then as time passes, the cost of course increases, and the depth increases as well, right? So you go down further. So as a drilling engineer, the routine operation you need to understand is that you need to treat the drilling fluid pump operation, bit selection problem during the drilling process, which kind of we covered, but in this part now we're going to talk about the cost of drilling and how much it costs. So one of the most famous drilling cost equations which is being used is this equation, which relates different time dependent components as well as the renting equipment cost together. So let's talk about this equation and see what components it does have. So it's CF, start with CF. This is the drilling cost per feet. So the way we report this number is dollars per feet. So how much it costs you to drill 1 feet of the wellbore. That's what it means. Okay. And we have the CB. CB is the cost of the bit, and that's dollar per bit. We usually use multiple drilling bits when we do the drilling, so it depends on, for example, you purchase a drill bit which costs you $20,000, and that bit you can use it, let's say, for 10 days. So that means that the cost of that bit is $2,000 per day, right? Now, how much basically you spend, how much would you drill within that depth? How much would you drill with that time of 1 day? Then that number can be used also in this equation. So cost of the bit is part of it, and you have this in here. We have cost of the rig, which is a time dependent component. When you use the drilling rig, there are multiple times that you just don't continuously always drilling, right? There is a rotating time, which is the drilling time. Your drill bit is rotating, and you are basically increasing the depths that you drilled, right? That is called total rotating time, showing with TB here in this equation. In addition to that, you have a non-rotating time, which you don't rotate, and that part is basically, for example, you are adding a drill pipe joint to the system, right? Or you stopped for some reason, so that's called basically non-rotating time. And then there is a trip time that, for example, you want to change your bits, right? So still that's part of your non-rotating time, but we have it separately. For a trip, you have to take out everything inside the wellbore, including the drilling bits, drill string system out of the wellbore, change, for example, your drill bit, install a new one, put it back. So that's a round trip going there, and that should be reported as a part of your drilling rig cost, right? And all of these numbers are reported in hours here. And finally, we have delta D, which is the footage drilled with this drill bit. So how much depth did you drill? So here you can see that we are talking about a single drill bit, because in the wellbore we don't just use single drill bit, right? So for each part that you are basically changing the bit, you have to use a separate equation, because your the cost of the drilling is different, right? In terms of the footage that was drilled using that single drill bit, how much trip time you had, how much non-rotating or rotating time you had. And for example, some drill bits may have a higher ROP, better quality, longer time for basically having it inside the wellbore, and you can drill more. So all these factors come together into this equation, and finally you report it as a cost per feet, dollar per feet. So as an example, let's look at this example here. It's a recommended bit program. It's being prepared for a new well using bit performance records from nearby wells. Drilling performance records for 3 bits are shown for a thick limestone formation at 9,000 feet. Determine which bit gives the lowest drilling cost. If the operating cost of the rig is $400 per hour, a trip time of 7 hours, a connection time of 1 minute per connection. So basically what we have here is we want to try several drill bits and see which one is the most optimized one before starting the drilling. And we got this information from the nearby wellbores, for example, in terms of trip and connection time. So we had some experience in the field, and we are using that experience to find the best bit that we can have. So all right, let's look at this. And we have each bit. These are the information given to us. The drill bit cost. There are 3 drill bits, A, B, and C. Each bit costs differently. We should mention that here the cheaper the bit doesn't mean that you may have a lower cost eventually, and the reason is that you may have much lower rotating time compared to the one that is more expensive, and eventually end up with higher cost if you use the lowest cost drill bit. So now we have a rotating time. You can see that, for example, for this drill bit, A is 14 hours, B is 57, and C is 95 hours. So you can see that drill bit C is lower cost but have a higher rotating time. It does have a higher connection time though, right? And also the mean penetration rate, so the one that we talked about, how many feet do you drill per hour, that's called ROP, or rate of penetration, or penetration rate. So for different drill bits are different. This is faster, it's cheaper but it's faster. This one is more expensive, so it's has a higher penetration rate, and this one which is slightly less expensive than drill bit B, has a lower value for the penetration rate. So this is important. You see there are combination of parameters. Some of the bits are faster, cheaper, some of them are more expensive but slower, but they have, on the other hand, higher rotating time. So all these comes together into that equation and tells you to select the best bit. So if we do the calculation for this bit, the simple equation, cost per feet, this is the rig cost. It was $800 per hour. So cost of the am I correct? No, that's the cost of the bit, the first bit, sorry. Yeah, that's $800, and then The rig cost was $400 per hour, so that's $400. Connection time, the total rotating time 14 hours for the first drill bit. You can see 814.8. Connection time is 1 minute, and then 7 minutes of 7 hours of 7 hours of the trip time. So we have all these added together, right? All the hours multiplied by the cost of the rig per hour. So these hours cancel out each other, and it gives us the drilling cost. On the other hand, you need to calculate the depths that can be drilled with that single drill bit, right? So if we go back here, you can see that the rate of penetration is 13.8 feet per hours, and then if you wanna drill for a penetration rate is 13 hours, and then the rotating time that you have with that drill bit is 14.8 hours. So feet per hour, which is the penetration rate, multiplied by how many hours of rotation you have, right? So this is the rotation time, this is the rate of penetration per hour, ROP, right? Per hour, and if you multiply together, you get how many feet you will drill, right? So that's why we are multiplying the rotating time by the ROP, which is the rate of the penetration. All this together gives you the cost. So that's $46.81 per feet. Now you can do this for all the drill bits, do the calculations, simple calculations, and eventually after you did the calculations for all drill bits, you will end up to having the drill bit to be the lowest cost. Although if you look at here, you see that this was the drill bit that had the highest cost in terms of just the cost of the bit itself, but eventually the drilling cost, which is cost per feet, drill bit B was the best one, because we had basically very good rate of penetration combined with the rotation time and less connection time. So that equation is being used for this, and in the next video we're going to continue this topic.